when we're talking about color, amplitude of a wavelength is important because the higher the amplitude in an electromagnetic wave, the darker the color is going to be. So our dark blue has a much higher amplitude than our light blue does. But we see that they both have the exact same wavelength. Okay, they're both types of blue electromagnetic light waves. They just have different amplitudes. So when we're talking about an electromagnetic wave, and the only ones that we're really going to deal with are light waves within the visual spectrum, okay, visible light, we're going to be focusing on the different colors and how the eye perceives all of the colors and the absence of color. So if all of the colors are white, what do you think the absence of color is? Black. Okay? This is one of the reasons that space is black. All right? The electromagnetic spectrum is the visible light spectrum that we're going to be talking about. And we always start it with our red. So red, orange, yellow, green, blue, indigo, violet. Roy G. Biv. So if red has the largest wavelength and violet has the smallest wavelength, if I'm going to draw a violet wavelength here, will it have a shorter wavelength or a longer wavelength than the green? Green will complete a wavelength in this distance. But violet, which is further along down the electromagnetic spectrum, starts at the same place, but it completes its first wavelength in a much shorter distance than it takes the longer wave to complete a wavelength. So in a set amount of time, if we look at this screen, we can actually count how many green wavelengths and violet wavelengths we have. So green has 2 wavelengths here. Now if I look at my violet, I have 1 wavelength here, I have a second wavelength here, I have a third wavelength here, and a fourth wavelength here. So in that set amount of time, okay, violet was able to get 4 wavelengths, and green was only able to get 2.5. Let's say 5. So in that set amount of time, who has the highest frequency? If we remember that frequency is the number of wavelengths in a set amount of time, who has the larger frequency? Violet has the larger frequency because we got more wavelengths in. Now, violet will have the higher frequency here, okay? Higher frequency. Now, the same thing goes if I want to make a lighter version of violet. I'm going to follow the exact same wavelength pattern here. I'm going to have short waves, which these should all be even, and they're not, whatever. You get my meaning, okay? The amplitude is much less than the actual original one, but it's the same color of wavelength, it's just a different shade. The actual wavelength for sound is very similar, except you need an actual medium, okay? When we're talking about a sound wave, the same vocabulary exists. You have wavelengths, okay? You've got amplitudes, and you've got an actual frequency, all right? The actual wavelength in a sound wave has everything to do with the pitch or the note that noise is making. So when we're talking about light waves, wavelength measures the color in nanometers. Red has a set number of nanometers of wavelength. Violet has a smaller one. When we're talking about amplitude in color, that has to do with the shade of the color. When we're talking about sound, the wavelength has to do with the pitch of the note. Okay? And that is, is the note a high note or a low note? That's why when you look at the choir is usually grouped into 3 types of singers. Okay, those sopranos, the altos, and I don't know what the really low ones are called. I have no idea. What? Tenors? There we go. Okay, and they can all make set sounds. If you put me next to Jillian McLaughlin, I can't make those noises. Okay, my vocal cords just don't work that way. All right? Now, just like in color, amplitude is important here. When we're talking about sound waves, the note at which your voice is heard is at a specific wavelength, at a specific pitch. So it will have a set wavelength. When you increase the volume, you're still speaking at the same pitch, but the volume is greater. Therefore, the amplitude is greater. If you're speaking at a lower volume, you're speaking at the exact same note, but the volume is lower, the amplitude of that wave will be lower.